the minimum number of carbon atoms an alkane should possess in order to exhibit optical isomerism is. So how many minimum number of carbon atoms are to be there in an alkane in order to exhibit optical isomerism? So what is the compulsory criteria for an organic compound to exhibit optical isomerism? It is nothing but chirality, isn't it? So under what conditions a molecule is said to be chiral? That is possible only when a carbon is attached to 4 different atoms or 4 different groups. So same way, in the case of alkane, at least there should be one carbon which is attached to 4 different atoms or 4 different groups. So first let me take a very simple example of methane. In methane there is one carbon which is attached to 4 hydrogens. As all these are same, it is not a chiral carbon. So this cannot exhibit optical isomerism. Same way, when you take the case of ethane, again there is no chiral carbon. Again in propane, there is no chiral carbon because a carbon need to attach to 4 different atoms or 4 different groups. Again in the case of butane, there is no chiral carbon. So now let me take the case of the compound which contain 5 carbon atoms, because it is very clearly given in the option. It can be either the compound with 5 carbon, 6 carbon, 7 or 8 carbons. So if I take one carbon at the center and remaining 4 carbons, one on each side. So this is the compound, this is the alkane with 5 carbon atoms. And again this is not chiral because this carbon is attached to 4 similar groups. So definitely an alkane with 5 carbon atoms cannot exhibit optical isomerism. Is it clear? So now from this structure it is very clear that there should be 4 different groups here. One of them can be hydrogen, that is the simplest one. Then the other one can be a group containing 1 carbon. And the third group can be a group containing 2 carbons. And the fourth group can be the one which contains 3 carbons. Now count the total number of carbons. It is 3, 5, 6 and 7. It is 7. If I extend this and write, it looks like this. This is CH2, CH3. This is CH2, CH2, CH3. So these are group with 3 carbons. So all these 4 are 4 different groups. So as this carbon is attached to 4 different groups, definitely this is chiral carbon and the molecule is chiral molecule. So what did you get from here? In order to exhibit optical isomerism, the organic compound, here it is the alkane. In order to exhibit optical isomerism, the alkane should possess minimum 7 carbon atoms. So answer is option C.